Fascinating Frontiers, episode 48. Hey everyone, thanks for joining me on another episode of Fascinating Frontiers. I'm Patrick, coming to you from Vancouver, and today is April 2nd, 2026. Let's dive into what's happening in space and science right now. We have to start with the story that's dominating headlines. Artemis 2, yesterday on April 1st, NASA's Space Launch System rocket thundered away from Kennedy Space Center, carrying 4 astronauts on the first crewed lunar mission in more than 50 years. This flight marks humanity's return to cislunar space, that vast region between Earth and the Moon that we haven't visited with people since the Apollo era. After decades of focusing on low Earth orbit, we're finally pushing outward again, and this mission is the critical dress rehearsal for the Artemis landings that will follow. I have to admit, I can't help but feel the weight of this moment. More than 5 decades have passed since we last sent humans that far from Earth. Watching the SLS lift off felt like closing one long chapter and opening a new one at the same time. The engineering that made this launch possible is genuinely remarkable. The rocket itself is the most powerful ever built for human spaceflight, and getting it ready for crewed flight after years of development has been an enormous challenge for thousands of people across the country. But spaceflight is never just about the glamorous moments. Right on the very first day of the mission, the 4-person crew had to deal with a very practical, very human problem. Their toilet stopped working properly. Using tools and procedures prepared on the ground, they troubleshot and repaired it while still early in the flight. It's the kind of story that reminds us that even on the way to the moon, astronauts are still people who need the basics to work. The quick fix ensures the crew will be comfortable during the 6-day lunar flyby, and it quietly demonstrates NASA's real-time in-flight troubleshooting capabilities. Spaceflight always sounds incredibly glamorous until you remember that humans still have to handle everyday bodily functions far from home. The fact they sorted it out so quickly speaks volumes about how well prepared both the crew and the ground team are. It's exactly the kind of quiet engineering win that keeps a complex mission running smoothly instead of becoming a distraction. Now, while we're celebrating this bold step back into deep space, it's fascinating to shift our gaze from the moon to worlds far beyond our own solar system. Because at the same time as Artemis 2 is flying, astronomers are quietly learning more about how planets and brown dwarfs actually form. Astronomers using the WMKEC Observatory in Hawaii have completed the largest survey of exoplanet spins ever conducted. They studied dozens of gas giants and brown dwarfs and found something that planetary formation models have long predicted. There's a clear relationship between a world's mass and how fast it rotates. More massive objects tend to spin faster, exactly as you'd expect if they formed through gravitational collapse while conserving angular momentum. This confirmation matters because it strengthens our fundamental understanding of how these distant worlds come together and evolve over time. It gives us a clearer window into the physics that governed their birth in the swirling disks around young stars. The data also helps calibrate the complex computer simulations that researchers use to model planet formation. When your simulations match what we actually observe in real systems, your predictions about worlds we haven't directly seen yet become much more reliable. I find it genuinely amazing how something as seemingly simple as measuring a planet's spin rate can reveal so much about its entire formation history. It's one of those beautiful moments where a basic physical principle, angular momentum conservation, shows up clearly even across light years of space. Speaking of new exoplanet discoveries, artificial intelligence has just delivered a major haul from existing data. A new machine learning system has validated more than 100 previously unknown planets and identified thousands of additional strong candidates in observations from NASA's Transiting Exoplanet Survey satellite, better known as TESS. This is a perfect example of how powerful machine learning has become in astronomy. Instead of teams of researchers having to stare at light curves for years, algorithms can now highlight the most promising signals almost in real time. The work also provides fresh estimates for how common different types of planets are around Sun-like stars, which helps us better understand the overall architecture of planetary systems. It's accelerating our ability to map out the incredible diversity of worlds out there. What used to take decades of painstaking manual analysis can now happen much faster, opening the door to discoveries that might have otherwise stayed buried in the data. While we're looking at distant planets, there's also big movement happening closer to home in the commercial space industry. SpaceX has taken the initial step toward going public, confidentially filing for an initial public offering. Industry leaders are watching this closely, seeing it as a potential watershed moment for the entire commercial space sector. If it moves forward, this could be one of the largest IPOs in history, and it really reflects how far the private space industry has come in just a couple of decades. What started as a small group of dreamers is now a mature sector that's reshaping how we think about access to space. That growth is also creating new opportunities for established aerospace suppliers. Teledyne has combined its imaging electronics and component lines into a new dedicated entity called Teledyne Space. The reorganization is clearly aimed at better serving the rapidly expanding space sector, and it reflects the growing demand across the entire industry. Companies are positioning themselves for what they expect will be a very busy future in orbit and beyond. Even smaller players are making interesting moves. A university spin-off called Aspect Aerospace recently raised $2.4 million. They're developing circuit board-sized satellites designed to fly in swarms in very low Earth orbit, where they'll monitor the space environment. The fact that this company grew out of the University of South Alabama makes the story even more compelling. It's a great reminder of how academic research can spin out into real hardware that eventually flies in space. These tiny satellites show how democratized space technology is becoming. You no longer need massive government budgets to contribute meaningful hardware to orbit. From these tiny satellites in Earth orbit, let's turn now to some intriguing theoretical work about the very early universe, because this next idea is genuinely mind-bending. A new theoretical paper proposes that microscopic primordial black holes might have detonated inside the quark-gluon plasma that filled the universe in its first moments. These explosions could have reshaped the early universe and influenced how matter was ultimately produced. To give you a sense of just how extreme these objects would be, if you could somehow shrink the entire mass of the sun down to the size of a single atom, you'd have something approaching the density of a primordial black hole. These hypothetical microscopic black holes are thought to have formed in the extreme conditions right after the Big Bang. At that time, the universe was still a hot, dense soup of quarks and gluons, a state we can barely imagine. Picture yourself riding along inside that seething plasma. Every so often, a tiny black hole would evaporate in a burst of Hawking radiation, releasing energy like a depth charge in that primordial sea. These explosions might have altered how the first protons and neutrons assembled, changing the chemistry of the early universe in subtle but important ways. The temperatures involved reached trillions of degrees, and the timescales were measured in tiny fractions of a second. Yet the idea remains strangely elegant. Black holes born in the first moments of cosmic history could have left their fingerprints on everything that followed. What keeps physicists up at night is figuring out exactly how many of these primordial black holes existed and whether their explosions left observable traces that we could detect today, perhaps in the cosmic microwave background or in the measured abundance of light elements. The work draws on ideas from researchers at Vrije Universiteit Brussels and the Massachusetts Institute of Technology. It's one of those theories that makes you completely rethink everything we assume about the first moments of creation. Even if it turns out not to be correct, it's pushing us to look at the early universe in new and creative ways. Staying with cosmic mysteries, astronomers are still actively debating an intriguing gap in the black hole population. There's ongoing discussion about whether there's a genuine desert between roughly 50 and 150 solar masses where stellar mass black holes seem to be strangely absent. Observations continue to fuel this scientific debate, and it's remarkable how much we still don't fully understand about how the most massive stars end their lives. New data keeps challenging our models in the best possible way, forcing us to refine our understanding of supernova physics and the processes that create these incredibly dense objects. Speaking of our own solar system, new observations have revealed something surprising about one of our giant planets. Saturn's magnetic field appears to be curiously distorted, and one of the planet's moons is suspected of playing a role in that warping. Understanding this complex magnetic environment is becoming increasingly important as new missions to Saturn and its intriguing moon Enceladus are being planned. The more we learn about these intricate magnetic interactions, the better prepared we'll be when we eventually send sophisticated spacecraft to explore that system in detail. While scientists study distant worlds, backyard skywatchers have plenty to look forward to this month. Venus and Jupiter are the standout bright planets in April's evening skies, shining brilliantly after sunset. Meanwhile, Mercury, Mars, and Saturn are visible in the dawn sky. If you know where to look, you can spot all 5 naked-eye planets with nothing but your eyes. It's a great time to get outside, reconnect with the sky, and remember that some of the most rewarding astronomy still happens right in your own backyard. The two brightest planets really light up the evenings right now, making it easy to share the wonder with friends and family. If you're enjoying the night sky this month, you might also want to mark your calendar for the moon's brightest nights. A new calendar has been released that details all the full moon dates for 2026. It does a nice job explaining how lunar phases are created by the precise alignment of Sun, Earth, and Moon. The changing angles of sunlight produce the familiar cycle we see from Earth. A full moon happens when our planet sits precisely between the Sun and the Moon. It's such a simple, elegant cosmic dance, yet it has guided human calendars for thousands of years. Looking further ahead, one new article draws some thoughtful lessons from space history for the next big steps we're about to take. The piece compares Robert Goddard's first liquid-fueled rocket flight in 1926, the launch of Sputnik in 1957, and the Apollo moon landings. It highlights how quickly progress can accelerate once key technological and political milestones are reached. The article offers useful insights for those now thinking about how we should develop future lunar bases. History shows us that after long periods of relatively slow development, things can suddenly move very fast. It's encouraging to think we might be standing at one of those tipping points right now. Finally, here's a beautiful human story that connects amateur astronomy directly to Hollywood. Stunning nebula images captured over more than 400 hours by one dedicated astrophotographer now appear in the end credits of the new film, Project Hail Mary. The whole project began with a simple message on Instagram. Now those photographs are gracing the silver screen. It's wonderful to see dedicated backyard astronomers getting their work celebrated in a major motion picture. 400 hours of imaging is an incredible commitment that shows what passion and persistence can achieve. Before we wrap up, keep an eye on how the Artemis 2 mission progresses as the crew continues their journey toward the moon. There's a lot more to come from this flight. That's Fascinating Frontiers for today. If you enjoyed the show, a rating or review on Apple Podcasts or Spotify really does help new listeners find us. I'm Patrick in Vancouver. Thanks for exploring the cosmos with me, and I'll see you next time. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.
Drifting softly through the black